Hardware and materials. As I rotate this around and kind of see where some of the washers and the nuts will go. So we need to activate. So we can either come up to options, maybe not, the options pull down, add-ins, there we go, and we're going to add the toolbox library. This has the same effect as coming over to the SolidWorks add-ins once it finishes and clicking on the SolidWorks toolbox. Just keep in mind that adds the utilities as well. So we go into the toolbox, we're finding the ANSI inch. We'll be looking for washers, and our call out, just kind of referring back to the bill of materials, is for a plain washer. So doesn't go too much further than that. And if I was just looking, there isn't anything that specifically says plain washers. So we're going to find the closest, and 060 16th of an inch thick. That ought to be pretty close. Preferred wide. Well, let's go ahead and drag one in. We'll place it. Okay, so that's a little bit bigger. Inside diameter 1.062. And the thickness 165. So since that's a little thick, we'll go ahead and kick it out and just X and cancel. Try a preferred. Alright, so I really want something that's off the shelf. See what the narrow looks like. So 2.25, and we're still in that larger range. Regular flat. Wow, that looks really big. Oh, size, let's see, 1 inch. So yeah, we're still not quite getting there. So if I have to, I will create one, and since it doesn't have the sizing, and outside diameter 3 inches as well. Okay, so I'd really rather find something that's an off the shelf, so I paused so that I could do some searching. Alright, so we have a 316 stainless and a black oxided 18/8 stainless that are both 1062 by 2 inch. It's a little oversized and it's a little thicker, but it's an off-the-shelf part. I don't have to order a custom or make something custom. The brass, probably not as much wear resistance as either of the stainless. So let's go back to the one. So preferred narrow, I'll place that. I'm just going to hover until it finds. Nope, didn't get it. So we'll just switch it over to 1 inch. 1.062 is the clearance. 2 inch is about the same size as our bracket. It's about twice as thick. So we'll just have to check and make sure that when we place this, we have enough clearance. Alright, so at the top of the groove, 1.12. So we're a little bit larger than the through hole. So that becomes a little bit of a concern, but let's go ahead and use that as an interference check. So we're pretty good there. Let's go ahead and, as a coincident, and then we'll pull the structural hex. Don't know if there was anything specific called out, just a standard hex nut. So drag that into place, hover until it kind of finds it. Well, that was close enough. And we'll double check. 1 inch 8. Alright, I don't have any more of those, so I can just pull this out and we'll add the coincident. Now we could also do the rotation. I didn't pay attention when it was placing it, but we should have got that lock rotation. Alright, so that one will stay, and we'll see if that's able to rotate. So still able to rotate because its mating component is able to rotate. So let's take a look at that interference. One of the quick checks would just be to select the right plane, come up to the section view, and 3, Control 4. Alright, so we look at the washer. Alright, so that was what I found interesting, is that they put the matching chamfer and then loaded up a washer. So this really would have seated in here, and if it wasn't a rotation, it was a compression, except for the clearance, and really there's not much clearance, so we'd have to decide between a flathead or possibly a press stud. I really have to question the necessity for that washer as a spacer. So our choices are to reduce the chamfer, make that a radius. This is a part that's probably going to be turned on a lathe, and the tool that comes in and removes that material can make a decent size radius as a stress riser, or to remove the stress riser and still have a desired result. So we get to our revisions, that'll be something that we'll want to check. Let's go ahead and go through the rest of the groups. I'm going to try. I haven't tried the smart fasteners in 2020 yet. Take extra time, lightweight components, nope, don't have those. Nothing needs to be resolved, so we'll go ahead and hit OK. So on the selection, we have the two. See if it was the faces or the groups. So let's just go ahead and add to those, see if we can get this group set up. Alright, so sort of. And I want a socket head. No, we're going to be doing hex head. So I need to edit the grouping. Yeah, it's not real happy with the series, so change the fastener type. We're going to go to a hex head. Alright, so we have the Hex Bolt, 1/4-20, length of 5.75. I don't think so, it wasn't that thick. In our list we have a 1.25. Yeah, looks like a 1.25. And auto update, that's fine. And let's see if we can back out, because I need to add another segment to that. Alright, so got the Hex Bolt. Now the smart fastener is supposed to do a stack up. So we need to auto size the hole diameter. It found that. Alright, so the top stack was the grouping. So let's add to the bottom stack, and we have a lot. Alright, so I want to pick a washer. Alright, what I find is that a lot of times I can do this as fast with the individual pieces, but we end up with a large group. So, and then the other thing is, if you're sending this out, there's a possibility that the toolbox items won't necessarily carry over. So add to the bottom stack a hex nut. And we should see the narrow flat and the hex nut, so let's see if that did it. It gave me some errors, so I'm not sure where it set it. So it added them, but I'm not sure where it added them to. All right, so when it works, and I will come back to this in another video. Yeah, let's try Control Q. And not sure what's hanging up here, so we need to go back and diagnose. The wheel bracket shouldn't. Concentric, coincident. Yeah, I'm not sure. Control Z. Nope, can't undo. There's no undos. Alright, so we'll have to go do a little more diagnostic. Okay, so one of the techniques would be just to edit the feature and let it go back and see if it will solve. Just updating the mate. And cannot be moved. And we could lock rotation on that, but I don't think that helps. Okay, and then sometimes we'll just try to delete one and see if that resolves the others. So not really sure what it added, or it didn't add, but now we're flush, so I need to go back to the wheel support, see what it's actually coincident to. So first I'll suppress, and then make the movement if I go back and edit the feature. So something added in the smart fastener that I didn't really want. Alright, so I'm just going to go ahead and clear the selection so I make sure that I'm getting fresh, and we'll go ahead and accept. Alright, so since that was suppressed, now I need to go back and unsuppress it, and that'll give me kind of back to where I started. So little strange things. Like I said, when the smart fastener works, it works well. I haven't used it in 2020, so I'm not sure if I keyed in something different, but like I said, we'll do another video as an add-on later on. Alright, so let's just find the hex head, and really, small assemblies, this is going to be fine. In large assemblies, it is handy to have those stack-ups go in and semi-automatically add all of the groups. Alright, so we said 1.75 or 1.25, so we can change that. Okay, and that looks good when I accept it. And we'll run around and get all of those. Just going to check real quick. We have 4. Oh, and those were 1/4-28, so we'll need to go back and adjust those. Alright, so if you're expecting vibration, loading, they're not really much of an issue. Alright, it didn't pull it up, so let's edit the toolbox components. And notice I selected the whole group, and I'm hoping that it will do the whole group. Alright, so 1/4-28, 1/4-28, 1/4-28. And if you're expecting vibration, then the finer threads are less prone. We could also stay with the 1/4-20 and put in a washer, even a star washer, lock washer, or when we're picking the, let me move that down a little bit, when we're picking the nut. So machine screw, hex, slotted, nut, castle, no, don't really. And those would be something more of an ergonomic where somebody's going to spike themselves on the end of the exposed. So we put that in. says odd 80, which gets disappears into the part. Quarter 20 is fine, and we'll run around and place. Let's go ahead and zoom up on it a little bit so I can see it better. There we go. So as I get right to that edge, that should give me my concentric and my coincident. So if they kind of bounce around a little bit, you'll get into that mode where you can add them pretty quick. Alright, so we need another quarter 28 by 1.75. And we're going to go Hex Head, Hex Bolt, apply. Again, no matching size, so I wanted to find the countersink, so it went the other way, from really small to really big. And this one was the length of 1.75, and so there should be 2 of these. Alright, and having such a big counterbore is pretty much, if you're going to use a socket, you're not going to be able to get a wrench in there for assembly, so you're going to have to plan on a socket or a driver to be able to, a hex type screwdriver to get in there and tighten those. So I used a machine screw. I don't think in this case there's going to be much difference between a hex nut and a machine. So let's switch that over to quarter 28 since I recognized it. And we'll go ahead and apply the other. Okay, and then the last piece will be the 632s. If they did anything on the shaft, there's something else in the rest of the assembly. All right, so we'll go back to the bolts and screws, and we are looking for a set screw, socket. Didn't really UNC set screw cone point. Alright, so cone point is going to dig into that bushing a little bit. Going to set it. If we get our press right, we won't really need to do too much. And 9/16 is our length. Okay, we have 1/2 inch, so we'll go with 1/2 inch. Alright, so not real sure. I mean, it's just going to make it sub-flush. And if we really needed a 9/16, that's another video that we could do to look at our base. Alright, so it added that. Alright, so we're building up a lot of hardware. This is where I want to add a folder. And add to new folder, hardware. And this is going to allow me to hide or basically treat this as a group. So in the socketed cap screw, and apply to mate. So we got concentric. So that one did not pick up anything. So I should be able to grab the point and outside, apply a mate. And coincident, let's see if it'll go coincident. That's more of a tangent. Yeah, I don't know that I really wanted since it didn't update, we'll go ahead and kick that back out. So just coming over to the list of mates, I can delete that out. And we'll go coincident. Still not moving. Interesting. There it goes. Give it a chance to catch up. Alright, we'll go to the next set screw. And we got the concentric. And we'll go coincident. Alright, so that one moved a little quicker. So let's see what this looks like in transparency. Alright, so even at 1/2 inch, that looks fine. I'm not sure why they went 5/60. We don't really need that much exposed, and with that much of the cone buried into the bushing. And some decisions that I'll want to make is, kind of leaning towards I'd like to have a flange bushing if it's going to rub up against this face. We don't really know what the separation between the parts is. A mate that I could add to move these and keep them symmetrical would be to come over to the two faces, pick up the right plane, and this is all a control select, and I saw the paper clips for the mate, and it automatically went into symmetric, so it jumped over to the advanced mates, picked up symmetry. What that does is when I move one of these, and it was supposed to go over the right plane, so I'm not sure what I selected. Phase 1, Phase 2 in the right plane, so it must have been the order that I selected them in. Alright, so let's move that back over. We'll go to the advanced mates, and I will pay more attention since I pre-selected that didn't quite work out so well. We'll go right plane for the symmetry plane. And the two faces. Alright, and that's one of the reasons why we're always going to want to check our result is error check at the point. So we'll come back, turn off the transparency, and then let's go through and pick some materials. So the wheel bracket, and you know, an advantage of having the assembly and not worrying too much about all of the data in the background is that we can be a little more efficient when we get to this point. So material, don't see anything there that I want, so I'm going to edit the material, and we'll find a 1020 would probably be a bar. Bar size, we could probably get 1018 or 1020. So just to pick something close, yes. Alright, and if I'm going to use 1020 a lot, which yeah, it kind of looks like that's going to be my preferred. Next time I go into the material, there we go. Since it's not in my quick list, we'll go over to the 1020. Let's expand that out a little bit if it'll bring it. Let's go across the tabs. So basic appearances, crosshatch, application. There we go, favorites. So I'm going to add it to the favorites, and since I'm going to be selecting it at least a lot, I hit OK. So A36 is kind of a low-grade steel, easy to bend. Used that in several applications, so it still shows up. I'll move it down some, maybe the plain carbon steel, and then really don't use rubber that much, so we'll just remove that one out, make some room for other material. 303 or 304 is a pretty standard stainless, so we'll go that route. So having edited, I can go 1020, and that will do both of the arms since they are instances of the same part. The pivot shaft, I think I already made that one stainless. No, so we'll make it 304, I believe was the tube that I specified. Alright, so in this case, the stainless is a lot more corrosion resistance, and it's going to be pivoting on the bronze bushings. I want a little more wear, a little more corrosion resistance in its operation. Alright, so the wheel, made that stainless for some reason. Maybe that was the one I was thinking of. The oil embedded, it's not showing up, so we'll edit the material. Look for copper alloys, aluminum bronze, phosphorus bronze, tin bearing bronze. I have to go look and see what the actual specification was, and some of these are a little bit long, so yeah, I always kind of think about how they're going to appear in the title block and how much information I really need. So let's pick the phosphorus. I know it's an oil impregnated bronze, so bushing, but that'll get us a start. And then the stationary arms, those will go back to 1020. Alright, so we've changed our appearance a little bit. We'd also need to think about what we're going to order. Typically, because of the corrosion resistance and just general strength of the stainless availability, the 18.8 is going to be a good choice for our generic hardware. All right.